In orbital notation, electrons are represented as a reminder, orbital notation is where we have boxes and we fill those boxes with arrows. Those are going to be single-pronged arrows. So single-pronged arrows is what I will choose for my answer. Write out the orbital notation for magnesium and then answer the questions below for how the electron configuration looks. So orbital notation for magnesium. Magnesium is Mg. On the periodic table, it is element number 12, which means I'm going to have 12 total electrons. The first and second electron live in 1s. The s block has one box, and I do have 2 electrons, so I'm going to draw an up and a down arrow. The third and fourth electron live in 2s. And I do have those 3 and 4 electrons, so I would draw 2 arrows. Electrons 5 through 10 are going to live in 2p. The p block has 3 boxes. I will draw a total of 6 electrons, and those electrons are going to be facing the opposite way. And then finally, my 11th and 12th electrons live in 3s, 1 box, and I do have a full s block here, so I do have 2 electrons. So as I'm going through and choosing my answers, I'm going to look at my actual drawn out structure here and answer accordingly. So my first orbital shown is 1s. It contains 2 electrons facing in opposite directions. My second orbital shown is 2s. And it contains 2 electrons facing in opposite directions. In a grand total of 1 box. Going back to that 1s option, I forgot to answer that second question, so my bad. So those 2 electrons facing in opposite directions is also in 1 box. My third orbital shown is 2p. It is going to contain 6 electrons facing in opposite directions. And I have a grand total of 3 boxes. The fourth orbital shown, this is my last orbital, is 3s. It contains 2 arrows facing the opposite direction in a grand total of 1 box. In shorthand and noble gas notations, electrons are represented as a reminder, in shorthand and noble gas notation, I am going to write out and put my electrons superscripted. So I am looking at the superscripted numbers, and that is going to be my answer. Those superscripted numbers are my electrons. Write out the shorthand for germanium and then answer the questions below for how the electron configuration looks. Germanium is Ge. And it is element number 32, so that means I'm going to have a total of 32 electrons. My first and second electron live in the 1s block, and I have 2 of them. My third and fourth electrons live in the 2s block, and I have 2 of them. My 5th through 10th electrons live in the 2p block, and there are 6 of them. My 11th and 12th electrons live in the 3s block, and there are 2 of them. My 13th through 18th electrons live in the 3p block, and there are 6 of them. My 19th and 20th electron live in the 4s block, and there are 2 of them. My 21st through 30th electron live in the 3d block, and there are 10 of them. As a reminder, the D block goes down 1 energy level. And finally, my 31st and 32nd electron live in the 4p block, and there are 2 of them. The first orbital shown is the 1s. It contains 2 electrons. The second orbital shown is 2s, and it also contains 2 electrons. The third orbital shown is 2p, and it contains 6 electrons. The fourth shown is 3s, and it contains 2. The fifth shown is 3p, and it contains 6. The sixth shown is the 4s, and it contains 2. The seventh shown is the 3d, and it contains 10. And the eighth shown is 4p, and it contains 2. Remember that this last portion where it asks how many does it contain, this is always asking not how many could it, but how many does it contain for that specific atom. Write out the noble gas notation for palladium and then answer the questions for the electron configuration below. Palladium is Pd. And so for palladium, I'm going to backtrack to see who my closest noble gas is. So I'm going backwards, and my closest noble gas is krypton. So I am going to put krypton inside of brackets. So bracket, krypton, bracket. And then I will account for any electrons that krypton does not have. So I have accounted for 1 to 36. Now I have to account for 37 to 46. So my 37th and 38th electron live in the 5s block, and there are 2 of them. My 39th to 46th electron live in the 4d block, and there are 8 of them. And that takes care of all of the electrons that weren't taken care of by saying bracket, krypton, bracket. The noble gas that we chose was krypton. The first orbital that I stated after the krypton was 5s, and it had 2 electrons. The second orbital shown was 4d, and it contained 8 electrons. The energy level for each orbital is represented by the coefficient. This large number in front of the orbital and the number of electrons is going to be what is representing my energy level. Write out the orbital notation for yttrium, and then answer the questions below for how the electron configurations look. Yttrium is Y. It is element number 39. So that means I have to draw out 39 electrons. My first and second electron are going to live in the 1s block. There is 1 square, and I have 2 of them, so I'm going to draw an up and a down arrow. My third and fourth electron live in the 2s block. one box, one up, one down. My 5th through 10th electrons live in the 2p block. P has 3 boxes, and I am going to have a grand total of 6 electrons. My 11th and 12th electrons live in 3s, and I do have 2 of them. My 13th through 18th electron live in 3p. And I am going to have a full 6 in there. My 19th and 20th electron live in 4s. My 21st through 30th electron live in 3d. As a reminder, we go down in energy levels when we go to the d block here. And I am full here. My 31st through 36th electron live in 4p. And it is full. My 37th and 38th electron live in 5s. And I have 2 of them. And then finally, we reach my 39th electron, which is in the 4d block. And I'm only going to have 1 of them. So 4d. And I only have 1 electron. Now I can go ahead and answer these questions. The first orbital shown is 1s. It contains 2 arrows facing in opposite directions. And there is 1 box. The second orbital shown is 2s. And it contains 2 arrows facing in opposite directions. And there is also only 1 box. My third orbital shown is my 2p. There are a grand total of 6 electrons that are going to be facing the opposite directions. Oops. Sorry, facing the opposite direction of their roommate. Not that one. My apologies. And there is a grand total of 3 boxes. My fourth orbital shown is 3s. There are 2 arrows facing in the opposite direction. And there is just going to be 1 box. After 3s, I am showing 3p. 3p, I'm going to have 6 arrows facing in the opposite direction. And there are a grand total of 3 boxes in the p block. After 3p, I have 4s. 4s, I have 2 arrows facing in the opposite direction. And the S block has 1 box. After 4s, I am dealing with 3d. 3d has a grand total of 10 arrows, and they are facing in the opposite direction. And the D block has a grand total of 5 boxes. After 3D, I'm dealing with 4P. In 4P, I have 6 electrons facing in the opposite direction. and the p block has 3 boxes. After 4p, we have 5s. 5s has 2 electrons facing in opposite directions in 1 box. After 5s, we finally have the 4d block. For my 4d block, I have 1 electron. And the D block does still have 5 boxes. Hund's rule states, Hund's rule is that the electrons have to occupy empty orbitals before double occupying them. So that is this choice here, that every orbital in a sublevel is singly occupied before any orbital is double occupied. Write out the shorthand notation for silicon, then answer the questions for how the electron configuration looks. Silicon is Si. It is element number 14, so that means that we have to account for 14 electrons. My first and second electron live in 1s, and there are 2 electrons that live there. My third and fourth electron live in 2s, and there are 2 electrons that live there. My 5th through 10th electron live in 2p, and there are 6 electrons that live there. My 11th and 12th electron live in 3s, and there are 2. And then finally, my 13th and 14th electron live in 3p, and I only have 2 electrons. My first orbital shown is 1s, and it contains 2 electrons. My second orbital shown is 2s, and it also contains 2 electrons. My third shown is 2p, and it contains 6. My fourth shown is 3s, and it contains 2. And my fifth is 3p, and it also contains 2 electrons. The Pauli exclusion principle states, the Pauli exclusion principle is that the electron spins must be opposite within the same orbital. So I am going to choose this last option here, that the 2 electrons within an orbital must have opposing spins. Write out the noble gas notation for selenium, and then answer the questions for how the electron configuration looks. Selenium is Se, and it is element number 34. As a reminder, for noble gas notations, we're going to backtrack and find the nearest noble gas in the past. That is going to be argon. So I'm going to say bracket, argon, bracket. And argon is going to take care of all of the electrons, 1 through 18, and I just need to account for any that argon don't have. So I need to start accounting for my 19th and 20th electron. So my 19th and 20th electron live in 4s, and there are 2 of them. My 21st through 30th electron live in 3d. Reminder that the D block lowers the energy level, and there are 10 of them. And then my 31st through 34th electron live in 4p, and there are going to be 4 of them. So my noble gas chosen was argon. My first orbital that I am showing is 4s, and it contained 2 electrons. The second orbital shown was 3d, and it contained 10 electrons. And my third orbital shown was 4p, and it contained 4 electrons. The off-bow principle states, the off-bow principle is that electrons must occupy orbitals in order of increasing energy. So I'm going to choose this last option here. Electrons are going to fill atomic orbitals from the lowest available energy levels before occupying higher levels.